You will find the next page in your section on weather, and if you will make a page for cold front, flip to the back and put warm front, stationary front, occluded front. So you need four pages in your notes, front, back, with the 4 kinds of fronts. So again, you've got the 4 types of fronts.
Tell you what, you do me a favor, Permita, will you screen back that over there and then let me run the PowerPoint over here? Do you mind? Will you mirror back up to the TV? So, because I was gonna put my PowerPoint on one and this on one, but I can't move both of them. So you can do this and I'll do the PowerPoint here.
All right, so first up is a cold front. So will you read what the introduction says on your online text on page 1, please, Nathaniel? So again, on your online science book, you're in the little section called Weather Front Interactive Art. And it's up on the side screen, and then I'm going to talk about a bigger picture of it over here. Okay, so Nathaniel, if you'll read us what it says on page 1 of the little section on the iPad.
Cold fronts. A cold front occurs when a rapidly moving cold air mass runs into a slowly moving warm air mass. Because cold air is denser than warm air.
Okay, I'm sorry. Back 1 page. What fronts are?
A weather front is the area where 2 air masses with different temperatures and densities collide, but do not mix. The collision is often causes storms and changeable weather.
Okay, so pause. So if we're looking outside today, we do not have a weather front. There is not a front. Okay, so a front, write this in your notes, a front is when 2 different air masses, and here's the key word, collide. Not mixing, they collide. And we know there are 2 types of air masses. There are cold air masses and there are warm air masses, right? We know that the cold air masses have more dense or less dense air. Obviously more dense air because the molecules are closer together, right? Therefore, density is when you have more mass in a smaller space. So cold air, the mass is more dense. That's why cold air sinks. That's why hot air rises. So writing in your notes, a front is when 2 different air masses, write the word collide. They collide. And the result is going to be active weather. The result is active weather. That means a change. That means it could be a storm, but it could also just be drizzle. It could be 2 days of just drizzle. That's a different front, but it's still not going to be this. This right here means there's no front around outside because we have a high pressure system that is controlling our weather right now because we have clear skies and we can see the sun. Because remember, there's 2 kind of pressures. There's high pressure and there's low pressure. Okay? There's high pressure, there's low pressure. High pressure, fair weather. Low pressure, active weather. Low pressure brings the fronts. Okay? So here's a common misconception people have. The L is not just for this. People think an L means a cold front. It does, but it also means a warm front and an occluded front and a stationary front. What an L means is a front, okay? Low pressure systems bring weather fronts. That's why when you see an L, you will see a line drawn from it with triangles or half circles. Red and blue lines with triangles and half circles. Everybody should know what I'm talking about because that was on the study guide, right? We had to draw that. So if it's blue with triangles, that's a cold front. Will it be attached to an L, a low pressure system? Yes. It will. So would a warm front, so would the others, okay? So again, a front means you have two different air masses that are colliding, and therefore the weather is going to change. Most likely there's going to be some kind of precipitation. You're going to have nimbostratus or cumulonimbus clouds, both saying that you know that means there's precipitation with it, right? Again, do not confuse any of these front names with the temperature. So can there be a cold front and it be really warm outside? Yes, of course. Can there be high pressure system outside and it be super cold? Of course. Because high pressure is a sunny, clear day. Well, it doesn't have to be totally clear, where we have the sun out, right? Where there may be a few cumulus clouds come through that are not weather makers, or some cirrus clouds way up high. But that's a high pressure system. Low pressure system is when a front is being brought through by the low pressure system. And there are 4 kinds of those fronts. All right, so now, Nathaniel, will you read the next page, page 2. Now, this is going to talk about a cold front. Okay, you'll read that page. This is page 2 of that little interactive art thing.
A cold front occurs when a rapidly moving cold air mass runs into a slowly moving warm air mass. Because cold air is denser than warm air, the cold air mass remains close to the ground and sinks under the less dense warm air mass. As the warm air rises above the cold air, the warm air cools. It soon chills to the temperature at which water vapor in the air condenses into droplets of liquid water. Towering the cumulus and cumulonimbus clouds form the drops of water produced by the rapid rise of warm air. Because cold fronts move quickly, they can cause abrupt weather changes. Strong winds and severe thunderstorms are often linked to cold fronts. If there is enough water vapor in the warm air, heavy rain or snow may fall. But if the warm air contains little water vapor, the cold front may be accompanied only by cloudy skies.
Okay, what's fun? I know. I knew the answer to the question. All right. This one is the most important one, okay? Again, don't allow the word cold to make you think a certain way this could be. Cold fronts, here's what they mean. If a cold front is coming through, that's when you would have a storm. Can a cold front come through and not have a storm? Yes. Will you have a storm without a cold front? Cold fronts are going to produce storms. Now, let me explain what Nathaniel just read in regular terms. All right, so I'll give you a second to finish writing those words you just wrote, and then I want you to watch up here for just a second. Before we do that, let's have Permita show the little 6-second clip that's on there. Okay, now, that right there is what's happening right here. Okay? The end of that clip is what you see a picture of on my slide. Okay, so everybody look up. I know you're in the middle of writing a note, but I'll let you go back to it in just a second. I want to say a couple things about this, okay? Let me just say it and then I'll have you write it down. Okay? Everybody look up. Look up. Alright. Cold fronts occur when a cold air mass, remember a front means there's two air masses that are different. Air mass is cold, air mass is warm. When a cold air mass, which is going to move more rapidly than the warm, moves in and collides with the warm, here's what a cold front's going to do. The cold air is going to push the warm air up. And you know that's only because, we know that because this is heavier, this is lighter. This is more dense, this is less dense. This is going to stay toward the ground. As this warm air is pushed up, here's the key part. This is the part kids miss. Why it happens. When this cold air mass pulls in, pushes the warm up, the warm starts cooling off. Ashley, what happens when you put a cup with ice in it and it starts cooling off? What happens around the outside of the glass? It gets covered with condensation. That's what makes rain. Correct? That's why it rains. The cold air brings in, pushes the warm air up. The warm air cools, condenses. That's what here's the thing. That's what makes the clouds have enough trigger to pour the rain out, right? They didn't quite have enough, but when the cool air pushes the warm air up and it condenses, it allows a cumulus cloud. That's what makes it become a cumulonimbus cloud. And if this warm air, so remember we talked about humidity, if the relative humidity of this warm air is high, then you'll have rain. If this warm air had a low relative humidity, you might not get any rain. Or you'll get less rain. So if it's a super heavy rain, what did it mean about this situation? Yes, Kimon?
There was a lot of relative humidity.
Perfect. There was a lot of relative humidity in this. That's exactly right. Who else had that answer? Okay, let's say it again. Kimani had it right. Cold front connected to an L, a low pressure. H's, fair weather. Low pressure, precipitation, active weather. If it's there's four kinds of fronts connected to a low pressure system. One of them is a cold front. Okay? Cold front, the cold air mass, which is automatically going to be heavier, not necessarily bigger, but heavier. You understand what I mean by that? Like, let's say this is lead, and the amount of heavy this is going to be heavier than if I had this much feathers, right? Because they're way less dense, right? But they're taking up more space, but this is more dense, so it's heavier. So this is more dense. It's going to come in. This is going to go up. Because it's going up, that's going to make it cool down. That's going to make the moisture in it condense into droplets with the clouds and rain. That's why those clouds will be active weather clouds. That's why they get the word nimbus in them. Okay? That's when they become cumulonimbus cloud or nimbostratus clouds with the cold front. All right? A cold front is going to be when you have storms. So if the low pressure has a cold front attached to it, it's going to be storms. What is the symbol for a cold front? Lincoln. What color? Blue or red? Blue. What shape? Triangles or half circles? Triangles. What? Oh, did you say half circles? Okay, blue triangles. No, blue triangles. Okay? Blue triangles. So write that in your notes. I'm going to be quiet for a second. Write down what you need to write down so that you know what a cold front does and is. And then for beta, you will move it to the warm front. Okay, and Izzy and Graham, make sure you're watching.
Hi, Graham.
This is the day that we taught the fronts, and it's important.
We're good.
By the time you watch this,
Okay, so Chloe's question was, the blue triangles mean a cold front. Yes. There's going to be more to that story in a minute. But yes, they do. And again, that should be in your notes. That's also in your study guide. Because when you take your quiz, you're going to use your notes. And if you're taking good notes, you're going to have good answers. If you're taking notes, you're not going to get full credit. And some of you know that I've come back to you and said, you know, this test, this quiz, you didn't score as well because you weren't actively engaged in the notes in class. Yep, you may. Notice what Lincoln did. He asked before he walked up there and sharpened. Correct. Kimani, question.
Why is the warm air mass usually bigger?
You know, I don't know. That's a good question. I don't know. I'll see if I can find out. I'll ask Mrs. Shimenti because she probably knows. Because she has all kinds of
I'll give you
science
$2 to
degrees.
find out today.
Huh?
So I'll give you $2 to find out today.
That's bribery.
Or you could pay back the 5 you already owed me. No.
Just that.
I will find out, Kimani. Seriously, I'll find out.
I'll find out for $5.
I have an idea, but let me find out.
I'll actually put you on it.
At recess, I'll pick Mrs. Shimenti's brain and she'll help me figure it out. Again, I think I know, but I'm not going to say because it might not be right. Because that cost me $5. All right. Now, warm fronts. Warm fronts. All right. Who would read the section that says warm front? Fred.
At a warm front, a slowly moving warm air mass collides with a slowly moving cold air mass because cold air is denser than warm air. The warm air rises over the cold air. Clouds, storms, and rain often accompany warm fronts. If the warm air is dry, scattered clouds form. If the warm air is humid, showers and light rain fall along the front where the warm air and cold air meet. Because warm fronts move more slowly than cold fronts, the weather may be rainy or foggy for several days.
All right. Will you please, Pramita, play the little animation? All right. So there are several things I want to say about this. So don't write any notes yet. Just wait. Good. I'll give you time to write it down. And I can repeat anything that you need. Like Chloe a minute ago, she needed to clarify one of the things I said. After I talk, then you can write. If I need to clarify something, I will. All right. One thing I didn't say about a cold front. Okay, listen. With a cold front, they move quickly. Remember what we said a minute ago about this? Look, remember we said this was a fast-moving thing? Okay? This is driving the bus. The cold air mass is the motion of the cold air mass is what's moving this by, and it's moving it quickly. Have you ever noticed if there's a severe thunderstorm, it doesn't last that long? They come on through and they're really active, but they don't last but just sometimes a few minutes. Most of the time, only a few minutes. They might last longer. That's only because there was such a big amount. But, so in other words, if you have a thunderstorm that lasts for a while, what that meant was it was a really large cold front. Okay, that came through, but here, nonetheless, it was moving through rapidly. And if you ever watch the weather and they interrupt your show and you're like, "Argh," and they're doing all that, they kept saying, "Please notice on the tracker that take cover in blah 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 blah," and then take cover in blah. And those towns change every just minute by minute because that thing is moving quickly. That's a cold front. That's a storm, right? Now, A warm front. A warm front can sit over you and move like it. Don't get me wrong. It is moving, but it's moving slowly. So think of a cold front like rabbit running by. Think of the warm front as a turtle walking by. So the warm front is going to move slowly. A warm front can set up showers that go the whole day. They can go for hours, if not into a couple days. So a warm front doesn't move quickly like, relatively speaking, like a cold front does. A cold front is not going to be there for hours. It's going to be minutes. A warm front can be hours into a couple of days. Now, that doesn't mean it's going to be 2 days, but it could be as long as 24 hours, 30 hours, till it totally clears on out. All right? With a warm front, you will not have a storm. With a warm front, you're going to simply have rain, or you may just have drizzle, or you may just have a lot of clouds. So what do you think would make the difference on that? The question is, what would make the difference on whether the warm front had actual just steady rain, or just drizzle, or just clouds, Fred?
How fast the cold air is going to the warm air.
Okay, something else though too. Chloe? That's it. How much moisture is in this warm air? It's again about, okay, look back at the cold front. Remember this? The amount of heaviness of the rain is how much moisture is in this warm air. On the cold, warm front, if it's going to even rain versus drizzle versus just lots of clouds, how much moisture is in this warm air? The relative humidity of this dictates the precipitation. What do you notice about the clouds in the warm front versus the cold front? What do you notice about the clouds in the cold front and the warm front? Give me some things you notice. There are multiple things you could say. Angela, give me one. Okay, there's no cumulo in which one? Yeah, the cumulo is in the cold front. Because remember, cumulus, they're going to be really tall. That makes sense. That's the one with the storms. In the warm front, no cumulus. What have I got now, Nathaniel?
Stratus.
These are going to be predominantly stratus clouds. Now, that also makes sense if you're going to be, it's like, say you're going to be socked in with clouds for like 2 days. It's going to rain a little bit and be just drizzle a little bit and then just be cloudy sometimes and other periods of rain. That's a warm front. And those are stratus clouds because remember, stratus clouds blanket the whole thing, right? Cumulus clouds are going to be big and tall, but they're not going to be a total blanket. That also makes sense why stratus would be with warm fronts. See, it all makes sense. It's not just random. Now, here's what a warm front actually does. You remember in a cold front, the cold air was driving the bus? That's why it's called a cold front. In a warm front, the warm air is driving the thing called a warm front. Here's the thing, though. Just because it's a warm front, this is important. You don't change how the air is going to behave. When the cold front, this was hard for me to understand when I learned this. When the cold front comes through, because it's already more dense, it's going to come across the bottom and push the warm air up. Well, when the warm air comes, it cannot push the cold air up. Not possible. What it does, though, is it just pushes the cold air onward. Okay? So the warm air simply, as it pushes into the cold air, it's going to make it go up, but it's going to push the cold air forward. So the question Kimani answered, I don't know for sure the answer to, but I do know this. There's always a larger warm pocket of air than there is colder. His question is why? That's what I've got to find out. Why it's always so much more. I'll double check and make sure, and then I'll tell you. All right? But there's always going to be more warm, and here's why. remember what I said a minute ago about if this is, I got this much lead, that's going to be more dense than this much feathers. But can I get enough feathers to be, that it would weigh more than that lead? Yeah, but it's going to be a lot bigger amount, right? But that's the only way the feathers could ever be heavier than the lead, right? It'd be a lot more. So if there's a warm front, there's going to have to see if this makes sense. There's got to be a whole lot more warm air to ever be able to move this cold air forward. Make sense? There have to be a whole lot more of this in volume to move that more dense forward. This won't go up, it'll just move forward. This can't go up, it's just going to go straight across. The cold air will not rise. The cold air will just scoot forward. And in our United States, that's going to go to the east most of the time. It's going to be going eastward from the west. Why? Prevailing westerlies. And by the way, the tropical maritime, the tropical continental, the polar, and the polar, those are the 4 kinds that affect the United States. So if somebody were talking about the weather in India or the weather in Europe, you wouldn't be talking about those things because that's not what influences their weather. Those are the things that influence this continent's weather. They would have other global winds that would influence their weather on their part of the earth. Yep, Jayla.
Is there more warm air mass because it's less dense and it has
Okay, well that's my thought. That's what I'm going to verify to make sure that's right. But that's what I think the answer is. But I'm not 100% sure if that's why there's more. But I think that's the reason why. But I will verify. Nobody's ever asked me the why. Nobody's the first one to ever ask that. But I think that's the answer. But I'm going to double check. Okay, so does that make sense? Okay, so what symbol do we use with the low? Okay, remember, if I ask you a trick question, a warm front would be with a high pressure. That's a trick. Of course it wouldn't. All these warm fronts will only be with low pressures because high pressure is sunny skies. And how many of you probably thought before we started studying weather that high meant warm and L's meant cool? Right? I did. When I was a kid, that's what I first thought. Yeah. So warm fronts will only be with low pressure systems. Cold fronts will only be with the low pressure systems. All the fronts will only be with low pressures. So think of it like this. Those fronts that we're talking about, they develop around a low pressure system. Anybody remember what you call a low pressure and a high pressure? You had to send me a picture of it. Do you remember? One starts with an A, one starts with a C. What?
anticyclone, cyclone.
Which one's which? So one turns clockwise, one turns counterclockwise. One's a high and one's a low. Which one's which?
Anticyclone turns clockwise and cyclone turns counterclockwise.
And which one's an L?
Anticyclone would be low and cyclone would be high.
So anticyclone is low and the cyclone is high?
No.
The other way around? Other way around. So, Liam, awesome that you were sitting there figuring that, saying all that, because you brought back up what you read in the book, right? Yeah. So one turns one way, one turns the other, right? One is fair weather, one is active weather. Yes.
It's much more common. Anticyclone.
So which is more common? High pressure. Well, no, let me rephrase that. Here's the way to say that. Which one influences larger amounts of land? High pressure. Because
like which one's more common? Like which would happen?
so that question, I would say, is probably about even. But here's the difference. Okay, so let's say there's as many low pressures as there are high pressures. The high pressures, though, are covering a bigger area of land than a low pressure would. So like a high pressure system could be making it be sunny for like 6 or 8 or 10 states of land. Like over several states, right? Whereas the low pressure coming through is just going to be affecting just that little area that it's moving over. See that? So a low pressure is not going to affect as much at the same time, but it's going to keep moving. But a high pressure is going to be affecting a larger amount of land. Here's how you remember that too. Do you have more days with active weather or more days without active weather?
Depends on what time of day.
Overall.
No.
Not, you can't count just like these last little bit. Overall, throughout the whole year, are there more active weather days or just regular no precipitation days? Regular. Those are influence of high pressure. So you have more days influenced by high pressure than you do low pressure. Great questions. All right. The symbol for a warm front is going to be a red line with half circles. Never ever put a triangle in red and never ever put a semicircle in blue. The triangles are blue, the semicircles are red. Think of it like this. Cold front blue, warm front red. Now, just real quick reminder, you know, if you go to the faucet in your bathroom and you have a red and a blue on there, you know red is the warm or the hot, and it's on the left, and the blue is on the right for the cold. Almost everywhere unless it's messed up backwards. Did you ever think, here, get this, in space, where you're talking about true temperature, the color, a hotter color is going to be blue, and the cooler color is going to be red. So a star that is reddish is much less hot than a star that is giving off blue light. And by the way, that's how they know all the stuff they know about the stars, is by the colors. They can tell because every hue of color represents a temperature. So Fred, say what you just said. Listen to Fred.
Fire, the part of the fire is highest usually.
The bottom.
Okay.
Right here. And it goes out and it gets more reddish out here, right? Yeah, that's right. Exactly right. But somehow we started representing cool with the bluish and warm with the reddish orange. But in reality, if you're looking at coloring of temperature, the scientific, it's backwards. All right. Now, the most common of the fronts are going to be cold fronts and warm fronts. The other two kind of fronts that we're talking about do not occur as often. I will also say this. The other two kinds of fronts are going to be a combination of triangles and circles. Who remembers that from you're doing your study guide, right? So the other two kind of fronts are going to be a variation of either triangles or semicircles. One of them's going to be just straight up blue and reds, and one's going to be purples. Purple. All right. So, Pernita, will you go to the next page over there? So, who would read it to us about the stationary fronts on the side there? Okay, Mason.
Sometimes cold and warm air masses meet, but neither one has enough force to break the other. The two air masses face each other in a standoff. In this case, the front is called a stationary front, where the warm and cool air meet. Water vapor in the warm air can represent rain, snow, fog, or clouds. The stationary front can remain stalled over an area for many days.
All right. And then, Permita, will you hit the graphic there? The little animation.
Okay, so let's look at that animation. So what it looks to me like is they had a standoff and then somebody passed gas.
Basically, yeah.
In the middle of
Okay, play it one more time. Okay, watch it. Here comes the part. Here it comes. Lots of adults say I'm very childish.
Yes, yes, you are.
Okay,
That's
so
fire.
here's the way that I would never. So I figured out a cold front and a warm front, and then I didn't really listen when they talked about the stationary and the occluded front because I was like, okay, if you'll just give me a second to help you think about what a stationary front does, okay? Is it like a cold front or is it like a warm front? What do y'all say?
Both.
A little of both, but it's not like a cold front in that it's just going to come through the big old storm and go by. But it's kind of like a warm front more than a cold front because it stays. But, okay, here's the difference. Okay, right here. So you've got the cold and you've got the warm, and you should be going, but wait a minute, that's kind of like a cold front a minute ago. No, the cold front was doing what right here? This only. The cold front was, look back at the cold front. Okay? Oh, that's the same thing. It's not supposed to be. I just realized that. Alright? Okay, that's not right. That was supposed to, on the other one, supposed to be having the arrow go like that. Because this is literally on, let me go back here. On this is literally pushing. So this shouldn't be here. This should be missing. It should be just that. It's going like that. So I've got to fix my slide. That doesn't need to be there. Okay? On the, wait. We were on the stationary front, weren't we? Okay. So on the stationary front, you notice the cold air again, right? But you don't notice it doing what? Going forward. You notice the warm air, but what? It's still on the ground. So what's different about that versus the cold front of indigo? It ties back to a question that was asked in the room of indigo. What is the difference right there? Kylie. Correct. That's the difference. It didn't say that in your reading, but basically what a stationary front means is the cold air didn't have enough to move all the warm air up. The warm air didn't have enough to be able to push the cold air away either, right? So there's about the same amount of energy from both. Therefore, they just sit. And they don't move. And then what you saw in the graphic was what comes up? Clouds. That creates the clouds that we just said was a... Alright? And if there's enough moisture in the cold or the warm, there's enough moisture in the cold or the warm, the warm, then you could get some rain from this or some drizzle, but you could just have a bunch of clouds. Which could also be the case on the warm front. But the difference on the warm front is it's going to move, although it's a turtle moving, right? It's going to move on by. The stationary front simply means there wasn't enough in the cold air mass to move the warm air mass. Or you could say it the other way, there was so much in the warm air mass, the cold air mass couldn't move it. So they basically have about the same amount of strength. So they just sit. And then in the part where they meet, that's where the cloud coverage is from. Okay? So the next question you should ask is, well then, how do they ever move? How they move is something else moves them. Another front moves it forward. Or a high pressure system
moves it forward. Let me repeat that again. A stationary front will not move on its own, but you're like, well, it eventually goes away because something else moved it. So that's why it might sit there for a day or two until some other front comes through and moves it on by. That makes sense? But it could even be that it wasn't another front that moved it, but a high pressure system moved it on by. Okay? So it could be, like, let's say there's a high pressure that's moving eastward, and it would make this move on. So it's going to sit there until it gets moved by something else. And some people aren't writing in your notes. You need to be writing in your notes because your iPad's not going to be with you when you take the quizzes. Your physical notes only. What's the symbol for the stationary front, Kimani?
It's like a line with the blue triangles on the top and the circles on the bottom, but I have a different question.
Okay, hang on. Let me get that to everybody first. That's correct. If it's a stationary front, you're like, oh, it's basically they're even. So you got the triangles going here and then a semicircle underneath. Triangle, semicircle. Triangle, semicircle. Oh, like it's on the thing here. There's an example. So it's triangle, opposite semicircle. Back triangle. And they're not on top of each other. It's every other, right? See how it's every other? This is the stationary. Yeah, it's just the stationary line. Yeah. No, it's exactly what you call it, the stationary line. It's called a stationary line. That's exactly what it's called. Yes, Betty.
Shouldn't the half circles be on the side?
That's just sitting there. Actually, this is pointing because that's wanting to go this way and that's wanting to go that way. So they're pointing because they're trying to go this way and that's trying to go that way. What was your question, Kimani?
My question was, so a warm front clouds moves like a turtle. The cold front clouds move like a
Rabbit.
not turtle.
Rabbit.
And a stationary front moves like a dead person that you need to wait for them to rock.
Here's my analogy. A little stubborn kid is like, I'm not moving till mom comes and picks him up and moves him. All right.
You were so fun.
I don't like the rotting better. Okay, last thing really quickly. Permita, move it to the occluded front. I'll get you out of your misery quickly. Okay, Permita, will you read the last one? Okay, shh.
The most complex weather situation structure at an occluded front. At an occluded front, a warm air mass is caught between two cool air masses. The denser cool air masses move underneath the less dense warm air mass and push it upward. The two cooler air masses meet in the middle and join this. The temperature near the ground becomes cooler. The warm air mass is cut off or occluded from the ground. As the warm air cools, its water vapor condenses and the weather may turn cloudy, rainy, or snow.
Okay, this is not the right slide for occluded front. Okay, here's what an occluded front would be. So here's how I know you're listening. Cold air mass, cold air mass. There should be another cold air mass here. And then warms in the middle being pushed up. So it's cold, cold, and warms trapped in between them. So an occluded front means two colds are meeting, but they trap a warm that pushes it up. So here's the warm. Here comes a cold, and they butt up here, and the warm is being pushed up. And the weather you have there is going to be similar to what you would have in a stationary front. It could be just clouds, and will all depend on the warm air that's caught in the middle, how much moisture's in it, right? How much moisture's in the warm air is to if it's going to be drizzle or a little bit of rain or if it's just going to be clouds. And what's the symbol for the occluded front looks like. By the way, the occluded fronts happen very rarely compared to the warm and cold fronts. You're going to have warm and cold fronts often. You're going to have stationary fronts, pretty regular. Occluded fronts are much rarer, more rare. Okay? Because you don't have, it makes sense. You don't have that many times when you have two cold air masses that trap a warm air in the middle. But it can happen. But this one's much more rare. What's its symbol look like, Betty?
Isn't it like a triangle and a half circle right next to each other?
It's also a triangle and a half circle, but it's purple. It's triangle and half circle, but it's purple. Again, not the right picture. And Betty, Permita, will you hit the animation for that? So you see, it makes you think of the stationary front a little bit. But the difference this time was that you had a cold on both sides that actually trapped a warm air pocket in the middle. So think of it like hot pockets for weather.
Okay, everybody knows the jingle.
Okay, yes.
I was gonna ask, couldn't a really long, like heavy storm happen with Occluded Front?
A long period of drizzle or rain showers, but not a storm.
What if it's just, like, is it possible?
No. Let me say this. Here's what could happen. You could have an occluded front that rained over you for a while, Kimani, and then a cold front, Kimani, then a cold front came through and moved it forward and then rained a storm after it, right? But it wouldn't be from that occluded front. Does that answer your question? But you could have, this could happen where it rained and rained and rained and rained, right? Now, last thing about this. So when we had the flood in 2010, that you may or may not remember much about, you were alive, but here's what happened that day. You had a large amount of moisture in the warm front, and it got blocked by another front, and it couldn't move on. And it just kept raining the moisture out over just Nashville in just a matter of about 24 hours. So that's why that happened. It was because of, it's almost like it was a traffic jam of fronts, and the high pressure that was on the eastern side on beyond wouldn't let it move on over. So it couldn't move like it normally should have, and it got stalled. It stayed right there and just kept on because there was enough moisture to keep on feeding that warm air, and it just kept raining. So that's what happened for that. All right. Permita, if you'll hit pause on that. If you have questions about it, it's time to go to lunch, and I will answer the questions when we come back. When we do come back, okay, this is not a time to start talking yet. I'm still giving directions. When we come back from lunch, I'll answer your questions about fronts. I will give you time to finish up if you haven't done the Ed puzzle. I will give you work time on your homework, but also we're going to play Kit and practice our vocab work. Okay, who saw the new feature that I sent you a picture of?
Yeah, blur.
Where you blur somebody out? Okay, who needs on the list? Fallon, Lincoln, line up. Matt, Liam,
No, I needed to take
A lot of many people have.
other people, come on.
Yeah, everybody has it. Skinny people, if you can see your spine,